So 9.2, horizontal asymptotes. So horizontal asymptotes describe the end behavior. Does anyone remember what I mean when I say end behavior? We did that in the polynomial unit. Like what it's doing all the way to the left and what it's doing all the way to the right. And we drew those arrows. Up, down, up, that kind of stuff. So in other words, it describes where the y values level off. So when x values are getting increasingly large, like as x is going to infinity, or increasingly small, as x goes to negative infinity. So it's what the y values are doing as x goes all the way to the left and all the way to the right. Now, we've only looked at end behavior when we've had one polynomial function. So we've never had it in a fraction form. So we've been able to look at one function that's on a single line, not a fraction, and look at it and say, this goes up, up, this goes down, up, down, down, down. And it's easy to just look at an equation and know that. When you have a fraction, we have different rules for that. So if you think about the denominator of a fraction is getting bigger and bigger and bigger and bigger, so it's raising it to the 10th power. Like it keeps getting bigger and bigger and bigger and bigger. What is the fraction doing? It's getting a lot smaller, right? Is this how your notes have it? Mm-hmm. Yeah. Okay. Because I have it switched. So if your denominator is getting a lot bigger, I always use the pizza analogy. Like if you have 1/3 of a pizza or you have 1/8 of a pizza, if the denominator is bigger, you're getting less pizza. Like the number itself is getting smaller. So if the degree of the numerator is smaller than the degree of the denominator, then the function is actually going to 0.
Which means it's getting bigger? Smaller.
If your denominator is getting bigger, the whole number itself is getting smaller, so it's approaching 0.
But if the numerator is getting smaller, then the number is getting bigger?
No.
The numerator?
If the numerator is getting smaller and the denominator is getting bigger, the number itself is getting smaller.
So they're both changing?
Yes. They're both increasing. I guess I see what you're saying. They're both increasing, but this one's only increasing by +1, +1, +1. Like it's not going at as fast of a rate as the denominator is. But if we switch it, so now we make the numerator grow faster, what's happening to the whole number itself? It's approaching, it's getting larger. And it's approaching what number? Infinity. So if the denominator is growing at a rapid pace, it's getting closer to 0. You're getting a smaller amount of pizza. But if you have the numerator getting bigger, the whole thing's getting bigger. It's approaching 0. So if the numerator is larger, then the function goes to infinity. But what if they're about the same? So let's test it. If the degree of the numerator is equal to the degree of the denominator. Let's test it. So I want you guys to get your calculator out. And what do I mean by degree? Like, how do we know that these degrees are the same on the top and the bottom? Remember what degree means? How do I know the degree of a function?
Is it like the angle on the graph?
Not the angle. When I read, so if I have like x squared plus 2x plus 3, what's the degree?
It's the 2.
It's the 2. It's like the biggest exponent.
Oh, yeah.
That's my degree. So if I'm looking at the degree of the top and the degree of the bottom, the highest exponent is what? 1, and then on the bottom, 1. They're both 1, so they're both the same. So I want you to type in 1. I'm going to give everybody a different one, okay? This is just typing it in. So, Courtney, I want you to do 1. Tommy, 2. 10. Elianette, 50. David, 100. 1,000. Megan, 10,000. Avery, 100,000. You guys, you pick one and help. Help the person that you think needs the most help.
I'll take 100,000.
No,
Thank you.
No, I just need you to type it in the top and the bottom and then get some sort of decimal to 3 to 4 places.
So I type in 100 and then I do.
Get for 1 decimal.
Okay. I didn't do that. Oh.
You got it. 1.75. Good. What about 10?
I got 0.806.
That's right.
Okay.
50.
My calculator isn't working.
Graham, will you type in 50? Just to check.
0.695.
Perfect. Is that what you got, Graham?
I'm still
Okay. Let me know when you get it.
Those 3 decimal 4.
It's okay. David, what did you get?
0.6811.
Good. Kylie?
Do you have the right answers? Or you just
Mm-hmm.
Oh, I did something. Wait. Give me a second.
Okay.
Hold up. Oh, gosh. Hold on.
So yours would be 2005 divided by 3001.
What?
2005 divided by 3001.
0.668.
You get 0.668.
6, 8.
Okay, what about 10,000?
0.668.
6668. And then 100,000.
0.6668. So 4 sixes and then an 8.
Okay.
And then a 1. Like, please.
Okay, we'll just leave it like that. We'll do 4 sixes because I don't want to leave us 3 sixes.
Yeah.
So what's it leveling off at?
666.
66666. What's the fraction of that? What's the fraction of that?
2 over 3.
15.
2 over 3. If you put this into a fraction, 0.666667, that's approximately 2/3. Do you see a 2/3 in the problem?
Yes.
You do? What are they? Where are they in front of?
2 X's
They're in front of the x's. So we can say this is going to blow your mind, y'all. This is just so cool. When the degrees are the same, we can say that the horizontal asymptote is the coefficients in front of the x's when the degree is the same.
So the horizontal asymptotes would be.
Would be 2/3.
So when
it's it's only.
you can just look
So-
But what about all the ones, like, what about 1 and 10? What?
1 in 10.
Those are different. Those are definitely not 2/3.
Whoever made this math sheet is messed up.
What do you mean?
But no, for all the 0.66666.
No, it levels off like what it's doing as it approaches infinity.
Okay.
Like not at first. It takes a little while to get there, but it's what it's approaching.
So
Okay.
It's only 1 horizontal asymptote, not 2.
So let's just recap what we talked about.
Did you get attendance?
If your numerator is less than your denominator, do y'all have less or greater?
Less.
You have less?
That's less.
Wait, for the first
We
one?
had that.
We
Okay.
have the same thing as you.
Okay. If your numerator is less than your denominator, I'm going to switch these because I have this little like acronym thing that's easy to remember. So I'm going to switch them, okay?
Greater than first.
Yeah.
Never eat soggy waffles.
Kind of like that.
Thank you, Tommy. You're slightly more.
The brute sour watermelon is the OG.
I think we learned that in, like,
Wait, no, we had it right. We had it right.
Oh.
We had it
Okay,
right.
I learned this in
We had it right.
Never ever sin.
Okay, so if the numerator is less than the denominator, meaning it is bigger on bottom.
I like that. It's simple. Bigger on bottom.
We say that the horizontal asymptote equals 0. Or I'm going to say horizontal asymptote at y equals 0 because we need to get in the habit of saying y equals. So our little acronym for that is BOBO. Bigger on bottom, 0. BOBO. Bobo. Bobo.
Bob zero.
Okay, if it's bigger on top, so our numerator is greater, bigger on top, our numerator is greater than our denominator. And the whole time we're talking about degrees. So if I was identifying case number 1, it would be like x over x squared or something like that, where you have a bigger degree on bottom. Case number 2 would be like x squared over x. So if it's bigger on top, we say no horizontal asymptote.
What's the
Acronym.
This is BOTN, B-O-T-N. Bobo, Botan.
Bob zero is much better.
So what would like a line look like when it's the numerator's bigger and the horizontal asymptote? Is it just like
It's just continuous, yeah.
I want to see John Wick chapter 3.
Then if the numerator equals the denominator, so if it equals or equal degrees, then you have a horizontal asymptote at y equals the coefficient, coef, of the numerator divided by the coefficient of the denominator. So that's how we got like the 2/3. Okay. Eats DC.
what?
Oh, I get it.
So eats is exponents are the same, divide coefficients.
Did you come up with these on your own?
No, but I guarantee you ask any junior that had this class last year, they will remember Bobo Bodden eats DC. You think you won't? Guarantee you. Anyone that had this class last year, they know what Bobo Bodden eats DC is.
They know
Probably you won't remember this next year.
Bobo Bodden eats DC.
Bob zero.
If you want to remember the eats DC, it is exponents
No, I'll never forget.
are the same,
The barn?
divide coefficients.
Ooh.
If you want to write that down.
I know.
Okay, keep in mind, a graph will never, ever, ever cross a vertical asymptote. They just never will. But the unfortunate thing about a horizontal asymptote is that they can cross.
What do you mean?
So great.
I know. They aren't important enough to not get crossed through. I know. So horizontal asymptotes are just kind of suggestions, but they can get crossed through. Vertical asymptotes are like truth, and they cannot get crossed through.
Like there's gonna always be a break.
Mhm.
Is that your
One.
integration there?
Yes, thank you. So let's look at the first one. Now, y equals 4 over x minus 3. Where's the exponent bigger? Top or bottom?
The bottom.
The bottom, so Bobo. Where's the horizontal asymptote?
0.
You knew it.
I'm
Bobo. Okay,
Are we
what
going
about...
based only off the coefficients to see?
Mhm.
Oh,
We're looking at the highest degree. Yeah. So the degree on top would... Okay, what about the second one? X plus 1 over 3x minus 6. Eats DC. So I've got...
divide coefficients.
1 over 3.
Yes! Y'all got it. Okay, next one.
They are not the same.
Bigger on top, bigger on bottom.
Bigger on bottom.
Y equals
Nothing.
0. Okay, try the last 3.
Oh, okay. Sorry.
Try the last 3.
Mix Bobo up.
No, wait a minute.
No. So the bottom left would be y equals 3, because you're just looking at the biggest one. Coefficients divide 3 over 1. Next one, bigger on bottom, so 0.
Would you cross it? Explain x plus 2.
And on the last one, imagine foiling that out. You would get an x squared over x. So this is none.
This is none.
Mm-hmm.
So you don't cross out the x plus 2.
Mm-mm.
Gotcha.
You could cross out the x plus 2's, and then you would have x over, you would just have x. So there would be none. That's a good point, David. I didn't even notice that. So if I crossed out the x plus 2's, I would just be left with x minus 5 over 1, or just x minus 5, which is a line. When you graph it, it's just a line. But there's no horizontal asymptote when you just have a line. But it is bigger on top still. So if you had that over 1, it would have an x on top and then nothing on the bottom, which would still be bigger on top. So now now that we have our knowledge of vertical and horizontal asymptotes, we're going to start graphing these functions. But we do need to remember how to find x and y intercepts. Throw back. How do you find an x-intercept? You set something equal to 0. You let the y equal 0. So whatever you get, your ordered pair is x comma 0. Whenever you're setting the y equal to 0. To find x-intercepts on a rational function, you just set the numerator equal to 0.
Can you explain why?
Because there won't be an intercept or a point on the y-intercept, or on the vertical asymptote. So when you're setting the denominator equal to 0, you're actually setting that x to 0, and that's your vertical asymptote. When you're setting the numerator equal to 0, that's your x-intercept. So the bottom is your vertical asymptote, the top is your x-intercept. And then if I find y-intercepts, you let x equal 0. 0, comma, y. So for this unit's purposes, we're basically just doing these two things since it's rational. We're setting the numerator equal to 0, and we're setting y, or x equal to 0. So let's try graphing this equation. We're going to put all the things we know together. First step is looking at this function. Could I factor anything and simplify? No. So that means I'm going to have, will I have any holes? No. So I'm going to put none here. I have no holes.
That's just because none cancel out, right?
Exactly. The next thing that we learned was vertical asymptotes. And what do I do to find a vertical asymptote? Set the denominator equal to 0. So I have a vertical asymptote at x equals what? Negative 3. Good. So I'm going to go ahead and draw that. What we learned today is horizontal asymptote, comparing the degree of the top and the bottom. So how would I figure this one out? They're the same, so divide. So I have it at y equals 1. 1 over 1. So I'm going to go ahead and draw that. Now I want to find the x-intercept. That's setting the numerator equal to 0. So what's the ordered pair? Does it go first or last for an x-intercept? First. And then for the y-intercept, you set x equal to 0.
On the bottom?
On both, the whole thing.
Oh.
So 0 minus 5 over 0 plus 3. Negative 5 over 3. And does that y-intercept go first or last? Last. So negative 5 over 3 is about 1, negative 1 and 2/3. So I'm just going to put a dot like right here. Then I can connect the dots. And rational functions typically go in opposite quadrants. And unless I tell you otherwise, or unless you find another point otherwise, you're going to assume it's in the opposite quadrant. So I'm going to draw it up here.
Do you care about the other quadrant one? Like
Yes. Not how it looks, but that it's in the opposite quadrant. The only way it won't be in an opposite quadrant is if you find like an x-intercept in one and a y-intercept in another. That means that they're in, like if they were next to each other. So if I had an x-intercept over here, they would be side by side. But for now, we assume they're in opposite. Okay? Let's try one more together, and then I'm going to let you try the next one by yourself. Okay, so steps are, you factor it, poles, vertical asymptote, horizontal asymptote, x, y intercept. And it's going to go this step by step every single time. So if I factor, what would that look like? Can I do anything to the top?
No.
Okay. What can I do to the bottom? X plus 4, x minus 2. Can anything cancel? Yep. So that means I have a whole where? 2. And what am I left with once I cross out the x minus 2's? 1 over x plus 4. So when I plug in 2, what do I get? 1 over 6. So I've got a hole like right here. Where do I have a vertical asymptote? Good. Gonna draw that. It's a little crooked. Okay, horizontal asymptote. 0. Bigger on bottom. I'm gonna write Bobo next to it. Bobo. X-intercept, I set what equal to 0? And if you want, write these hints next to it if that helps you. You can set denom equal to 0, set numerator equal to 0. When I set the numerator equal to 0, I get, if I'm setting this equal to 0, I get 1 equals 0. Does that make any sense? No, it doesn't. So I say none. I don't actually have an x-intercept. Which, why don't I have an x-intercept? Because I've got what there?
A hole.
Not a hole. What do I have on the x-axis? I have a horizontal asymptote. And while I said it can cross it, it typically doesn't. So usually when you have an asymptote on the x-axis, you don't have an x-intercept.
So when I'm straight, you only look at the factor for it.
Uh-huh. I'm only looking at this now.
Wait, Mr. Finley, can you show me again how you got 1 is equal to 0?
By setting the numerator equal to 0.
Okay, so x
And-
minus 2 equals 0?
No, the new numerator after we yeah.
Okay, which is
So
1.
now we only, like, we can forget the original equation and only look at this one. What about y-intercept? What do? I set x equal to 0.
Make
1 over 4. You could get negative 2 over negative 8, but that reduces to 1 over 4.
Wait, so how did you get negative 2 over negative
I said x equal to 0. There, I don't have anything to plug into at the top, so I leave it as 1. 0 plus 4.
Yeah, I did the wrong thing. I went to
The original.
Yeah.
You can do the original, but it's easier to just stick with the new one and never look at the original again. So 0, 1 over 4 means a point right here. Ish. Then I connect. Oh no, did it go away? Oh, that's so frustrating. I hate when that happens.
Why are you using a different app?
Dosary?
Yeah, because you used a different one. Like you could scroll it.
Are we doing domain?
I don't think so. Yeah, we're going to do domain and range. So we said right here. What's the vertical asymptote? Negative 4. Sorry, guys. Okay, so then it goes like that. And we're going to put it in the, which other quadrant? The opposite one. Also, just to kind of go back to graphing rationals, our final answer was 1 over x plus 4. Does that look familiar?
Yes.
Like graphing that?
Yes.
The transformation is what?
Left 4.
Left 4, and it's positive, so that means that my quadrants are in the top right, bottom left. Okay, domain and range. Domain's from left to right, range is from bottom to top. So if I'm reading it from left to right,
Negative infinity.
negative infinity, where does it stop?
Negative 4.
Negative 4, union, then what?
Negative 4.
Negative 4, do I stop anywhere else?
2 of a hole.
We got a hole at 2. Then I stop, union, then I start again at 2, and I go to infinity. So I stop for discontinuities, which means breaks, or vertical asymptotes, or holes. My range,
Oh no, it's not. Is it like infinity?
negative infinity, it stops at my horizontal asymptote, so 0, union,
0 to infinity.
0, I stop somewhere, my hole, what's the y value of my hole? 1, 6, good, union,
I don't like this at all whatsoever.
1, 6 to infinity. So I'm just stopping at my hole. Okay, I want you to try number 3, start to finish, and it's not hard to graph because it ends up. Well, I don't want to spoil it for you. I'm not spoiling it. So from there, when you've reduced it to y equals x plus 2, and you've figured out that there's a hole at x equals negative 3, you plug in negative 3 into this formula, so negative 3 plus 2, which equals negative 1.
Oh, that's why.
Okay, I got the holes, and I got everything except for the x and y intersection.
Well, the x-intercept, you set the numerator equal to 0. So x plus 2 equals 0.
So what
X equals negative 2.
So I set it equal to 0
Okay.
instead of pointing in 0.
And then you set y equal to 0 for y-intercept. So y equals 0, 0 equals,
You set x equal to 0 for y.
that's what it is. Set x equal to 0. So y equals 0 plus 2. So 0, y equals 2. But even if you forgot that and you just graphed it, you would know there's a y-intercept at 2 because of this equation. Up 1 over 1, up 1 over 1. And then in the opposite direction.
That'll get you good.
Then domain, you stop at your hole. And range, you stop at your hole.
Okay, I get it now.
Okay. Okay, that's because... No, don't graph it yet. I just graphed the asymptotes.
I use your fancy highlighter.
Wait, I thought the equations were the same.
Okay,
They are the same
So then why do you have a y equals 2?
because you divide the coefficients. 2 over 1.
Avery.
2 over 1 is 2. From here, I'm going to plot my x and y intercept, which is only that I only have 1 point. And how do I graph it if there's only 1 point? Right? That could be difficult.
It's pretty difficult.
So I need to test points, and I don't need to get actual numbers. I just need to know what direction they're going in. If it's like in the positive direction or the negative direction, okay? So I'm going to test a point to the left and a point to the right. And I could do -1, -2, -3, -4. So let's just do -2 and +2. Let's just test those points and see what it's doing to the left and the right, okay? If I plug in 2, so I'm just going to make myself a little chart here, x and y. I just need to decide if it's positive or negative when I plug in 2. I can either do this in my head or I can work it out. All I need to know is it going up or is it going down, okay? So when I plug in 2, I get 2 times 2 squared, which is positive. I get positive on top. But then when I plug in 2 squared minus 25, is that positive or negative on the bottom? Negative. So the whole thing is what? Negative. Because positive over negative, the whole thing is a negative number. So that means it's going down. So I know for sure it's going down this way. Other way. It was +2. When I plug in -2, do I get positive or negative on the top? Positive on top. When I plug in -2 on the bottom, negative. So the whole thing is negative. So it's going down. Then I've got stuff going on the other sides. They're in the opposite quadrants. So I've got stuff going here and here.
I'm telling them. And can we? I remember this from the notes.
You can assume that it's in opposite quadrants. If you wanted to test points, you could. So you could test like -6 and +6 if you wanted. And you would just want those answers to be positive. So if like 6 squared minus 25, is that positive or negative? What's 6 squared? 36 minus, so that's positive. So it means it's up here. Positive.
Oh gosh, calculator.
Whoops. Okay, now let's think about the domain here. I don't have any holes, so that makes life easy. That means I'm just going to my vertical asymptotes and stopping, and starting again, going to my vertical asymptotes, and then going to infinity. So you're going to have 3 of them. I want you to try writing the domain. You're stopping at vertical asymptotes.
Where'd you get the 5 from?
The vertical asymptotes. So you only stop at vertical asymptotes and holes, but we don't have any holes here. Range, so I'm going from bottom to top, going all the way from negative infinity, and where do I stop? 0. Interesting. Do I have anything in this space from 0 to 2? No, so I have to stop. Then I start up again. Where?
0.
No, I don't start up again at 0. 2 to infinity. All right, so now we've got these 2 points. We want to test some points to see where it's going. And we just need positive or negative, okay?
Yes.
So we need things to the left of the vertical asymptotes and the right, and then in the middle.
Wait. Okay. Not in like a sarcastic or like a joking way, but like what are like why are we doing that?
We're just seeing like, okay, what's it doing in this quadrant? Where's the graph? Where's the graph here, here, and here? Like where is it? Is it above the horizontal asymptote or below, or does it go through?
Miss
But what does
McKinley,
that
this is
do
one
with
of the
anything?
instances
To draw it, okay?
horizontal asymptote is crossed.
Yes.
So,
Okay, so we're going to test some points and just see where it is. Now, let's try -2 and 2. When I plug in -2, and I just like to put like positive over negative or whatever. When I plug in -2 on the top, do I get a positive or negative answer? Positive. When I plug in -2 on the bottom, negative. So I get a negative answer. So that means that it's going down. When I plug in +2, what do I get on the top?
Negative.
And then when I plug in -2 or +2 on the bottom, I also get a negative, so it's a positive.
okay, so it makes like,
So it makes like a little S shape.
okay, but it doesn't have a, but
Kinda looks like an
It doesn't have
XQ.
a power of 3 or 5 or any odd number.
It's a rational. Rationals can do whatever they want.
Okay.
Okay, now I want to find what it does to the right and the left of the vertical asymptotes. So let's pick another. Let's -7. You can do -5 if you want. And how about +5? So let's do -7 and +5. Let's start out with -7.
It's a negative on top
Negative on top,
and a negative on bottom.
negative on bottom. So you end up with a positive. So that means it's up here. And it curves the axes. So we probably assume with the 5 it's going to be below, but let's test it.
It is.
When I plug in a 5 on top, positive or negative on top. When I plug in a 5 on the bottom, it's positive. So the whole thing is negative. So it's down here. Okay, last thing is domain and range. I've got no holes. So domain, I'm going to start at -infinity and I'm going to go to what?
-4.
Perfect. Then I'm going to start again
-4.
and I'm going to go until,
3.
and then I'm going to start again
3.
and I'm going to go till,
Positive infinity.
perfect. You did it. Range,
Negative infinity.
Isn't it a real number?
it is. Does it stop at the horizontal asymptote or does it go through it? Oh, it goes through it. So -infinity, +infinity, or you could say all real numbers.